Problem 6, ZigZag conversion. In this problem, we have a word, right? We are given a string. We're given a string and an integer. Now, this integer represents number of rows, right? So I'm going to actually use zero-based indexing because that's going to be useful. So basically, we have to create initially 5 rows, yeah. And here is zero-based indexing, 5 rows. And we'll take this initial word and write it out in a zigzag like this. Okay, so it will go in a zigzag into that sort of pattern, if you can see what I mean, right? So that's how we're gonna write our letter, our word. So for example, let's try it. So our word here is anti-disestablishmentarianism. Anti, A-N-T-I, this is tab and then I'll just humanitarianism. So I don't know, maybe I'm making a humanitarianism, something like this. I mean, I could have easily made a mistake somewhere. It's not an easy word to spell, especially in a zigzag form. So something like that. But I think I have this prepared actually, right? It's also possible that I've made a mistake here as well. But this should be the same word spelled in this zigzag manner, right? So so this is going down, and this is going up, and then this is going down again, and up, and so on, right? So down and up. And after we are done with this, what we have to do is take this first row. This is the first row. But obviously, these spaces are not actual spaces. So there are no spaces here, just ASMN, right? So the first row is ASMN, then NETH is the whatever. This is this next row. So we're going to write these out just like I have it here. So this is the final output we have to give. Okay, this is the final output. So this bit here is the first word. The first row. So row number 0. And then this right here is the next row with index 1. Yeah, this one here. And the blue bit is next row still. That's index number 2. It's this one here, and so on and so forth. So we need to basically output this result. Okay? Just to repeat, we take this word, turn this into that many rows in a zigzag form, like this. Okay? And then we take the first row, second row, and just join them into a word like you have at the bottom here. And we return that final single word. So it will be the same string, the same string, same length, but just letters will be in a different order. So an anagram of sorts, right? I will probably try to write 2 different solutions of this because I have 2 different potential solutions in my head. And the first one maybe is the straightforward one, right? So basically what I will do is I will create the required number of rows each will be, it could be a string. So each one of these rows could be stored as a string, but perhaps we could just play with an array. Instead of string, we'll just have an array of characters. So if you have 5, then we'll have 5 array of characters in an array. So it's going to be a 2-dimensional array of strings for JavaScript. Say if you're doing this in C++, it would be array of 2-dimensional array of characters, but in JavaScript, this will be 2-dimensional array of strings. And then I will basically notice that a single cycle would be this bit here, right? So going down, actually, this isn't really ideal. I think what I should do is going down like this, yeah, and this letter D, I should imagine it here, right? So, and then I would be going up like this, yeah? And I will repeat this as many times as necessary until I run out of letters, right? Again, this letter L, I'll imagine it here. So, and then again, go down from the very first row until the penultimate row. And then I'll start from the last row and go to the pen first row. I don't know what the word is. Not the initial one, but just the one with index 1. That would be row with index 1. If that makes sense. Okay, so let's try to implement this first. Well, as I said initially, first I'm going to declare our rows, which would be, let's create array from, and this will be, we need number of elements would be num rows, right? So num rows is this thing here. Now, what's going to happen to each element? Each element would be, this is the mapping function, right? Which will define each element. I don't need anything as an input to this mapping function. Instead, each element would be a new array of strings, yeah, of length 0, an empty array of strings. Okay, excellent. Now we are going to this sequence. Basically, as I said, this will be the outer loop, right? We're going to be running through these things. And in order to do that, let's write a loop like, first, let's create an index that will be pointing to a current letter inside of this word, right? So we're going to, I initially will point to the 0th element, 0th character in the letter. Then it will move to the first element, first character, second character, and all the way to the very last, okay? So that will be our index of the character, and we can run it while I is less than s length, right? We could also turn this into maybe a for loop. We could do that. Should we do it? Yeah, so let's do a for loop instead. So for let I equal 0, and then we could also do an increment here rather than inside. So this is actually not, yeah, this will be empty. I'm not going to do an increment here, actually. And you'll see why, because the increment will happen more frequently, let's say. So we're going to increment not only when we move from one of these big things to the next big cycle. Instead, we're going to increment I every time we do this, right? So that's probably why I had an intuition to write a while loop, yeah, which it's still not a bad choice. It's only I do not need this variable I outside of this loop, so maybe that could be the justification for writing it as a for loop. So here I'll have two loops, right? Let's say let row start from 0, and row should be less than, now this is a 0 index, right? Num rows minus 1, because as we said, I'm going to go to the penultimate row, the last row's index, because I'm using 0-based indexing. The index of the last row is num rows minus 1, and I want one less, so strict inequality here, right? Now, what that also means is if num rows is 1, my program will not work. You can see that because that loop will not be executed because I'm going through all rows except the last one. And obviously, if I only have a last row, just a single row, that's the last row, and that won't work. So I need a special kind of handling for situation when num rows equals 1. But I'll do this in a minute because we still have a hope that maybe in the second loop, because there will be two loops of like this, maybe in the second loop we'll handle the last row. But I think you can see now that that won't be the case. But anyway, still write both loops anyway. So what I have to do here is I'm going through these rows, right? So rows with an index row, and then push. What should I push? I should push a letter from this, a character from the string. So S with an index I, but I'm going to post increment this I, correct? I think that makes sense. So I'm going to grab that letter and instantly I'm going to increment. So after I grab the letter, the character, I'm going to increment the pointer to the character. So what I've did so far is I have done moving into this direction to the penultimate row here. Now this A, I'm going to imagine to be sitting here. And I'm going to start from the bottom and go all the way up. But I'm not going to touch the first row because that will be done in the next cycle, right? It will be done here. So that's the second loop I have to do. So let's do that second loop. Now the second loop will be start from the num rows minus 1, because we said that was the last row, right? So we're going to start from the last row. And then we're going to do every row except the very first. The very first has index 0. So all of those that are above 0. And then here we'll have minus minus. We're going to grab this letter or character with index I and instantly increment I, right? So these are very similar loops. However, two things. So first of all, as we said, both of these loops will not work if num rows is 1. So we need to handle num rows equals 1 separately, which is easy to handle because we're just going to return the initial string, right? Because if you want to rewrite this as a zigzag into a single row, it's pretty clear it's going to be the initial string. So In every other case, these two loops will do the trick except for one problem. We could fall off the end of the cliff, end of the string. Yeah, we could run out of the string. So that condition and this condition isn't enough, right? Because if suddenly we run out of the letters in the string, that would also be a problem. So this condition has to be applied here as well. So we should say, right, we should say each time we should check if we still have a letter in the original string, right? And we're still in the, let's say, one of those loops. For example, if we're still going in this direction, we still haven't reached this final row, or we're going into this direction and we still haven't reached the first row, right? And we haven't run out of the letters in the initial word. Now that we've done this, so rows array is kind of ready to be returned after certain manipulations. So first we have to map each row should be turned into a string. So we're going to join each row with an empty string. And then once this will turn basically our rows into an array of strings. Yeah. So rows won't change itself, that array, but it's a new array. This bit produces new array, which is an array of strings. And we also have to join this up with an empty string. So that now is exactly what we want, right? So let's see if I've messed up things, if there are any typos or any other problems. Well, seems to be okay on the pretests. Let's see how this fares with the actual full suite of tests. So it passed, wasn't really spectacular, beat only 20% of the solutions in terms of speed, and a slightly more, about a quarter of solutions in terms of memory efficiency. I'm not surprised with memory efficiency, obviously, because, see what I'm doing. I'm creating a new array here, completely unnecessarily. I mean, if we were doing this, if we were focused on efficiency rather than readability, then this is horrible, of course. But if you're a developer, then this is probably how you would actually do this. Okay, so we have a first solution here, right? But maybe we could think about a different solution. You know what? Maybe I'll copy this solution so that I can publish this solution later with this video. But now let me clean this up and try to think of a different solution. So what we were doing is, in the first solution, we were going through the original string from left to right, and then basically following the algorithm described in the problem statement, right? So the problem statement basically told us how we can convert the original string into the resulting string, and we basically just followed it. We put this letter here, and then the second letter, and the third letter down there, etc. But that created a little bit of some sort of inconvenience. If you remember, we had to check too many times whether we had run out of the elements of the string. We had to check it multiple times. You probably saw that in the program. What if we instead traverse the resulting string and just somehow come up with these letters and pick them up from the original string, from the correct place each time? So we find next element and put it here, then we somewhere find the next element and bring it here. So that sort of algorithm, yeah? So that's what I want to try to do. Now, this will not be a kind of natural implementation of the problem statement that we have here, right? Because the problem statement is kind of, it describes the algorithm. So this second implementation, we won't be following the algorithm described in the implementation. So we'll probably need a little bit of maths here, right? We'll have to come up first with all of the letters from the row 1, okay? And let's do that, in fact. So let's come up with this. One by one, we're just going to come up with these letters here. Now, the index of the first letter will be 0 inside the original string. It will be 0, right? This one. So let's give it index 0. And then what is the distance between each of them? That's the size of each of these little cycles here. They're not so little, though. So the size of each of these is what? It's twice r minus 1. And to see why this is the case, so we go down all rows except for the last one. Yeah. Now let's imagine this D is actually here, right? So we go down all rows except for the last one, and then we go all rows up except for the first one. So twice r minus 1, okay? And that's kind of our D. That's our D, right? That's how we defined D. Right, so we can write that. Just some preparatory work. Let's create answer, set it to an empty string. What else do we need? And then let's create D, which is twice, you know what? R minus 1 sounds nice. So I'm going to rename num rows to R, capital R. And now I could do this little loop. So for I equals 0, and I will be, this I is an index of a letter inside the original string, inside the input string. So I will be pointing here somewhere, okay? So I starts from 0, as we said, and then I must be within the string, and I will be increased by D each time, okay? And answer, we're going to add SI to the answer, okay? So that will pick out the correct letters for the row 1, right? And then we're going to add each letter one by one into the answer. So if this is our first row, now the last row will be very similar. Last row, but I mean, we can't just do last row instantly. We have to do rows starting from 1 all the way to r minus 2, correct? So we're going to skip the row with index 0, and we're going to skip the row with index r minus 1, because they will be the first row and the last row respectively. But the last row will be very similar, yeah, except for the starting position. The starting position, we have to figure it out. So this is this letter D, right? So this letter D, the index of this is what? Isn't it r minus 1? Because R is the number of rows. And this is the last row, basically. Indexed with 0. Characters are also indexed with 0 inside the string. So the index of this will be r minus 1. R is 5. So this will be 4. So 0, 1, 2, 3, 4. Yeah, and that's it. That's correct. So we're going to start from, didn't we say r minus 1? Yep. And this will be the last row. And once we're done, so don't forget we haven't done all of the in-between rows, but once we're done, we're going to return answer, correct? Yeah. Now we need to do all of the rows in between. Okay. How are we going to do that? Now notice that every row in between will have 2 characters. Well, maybe except for the last cycle, we may be missing the left bits in some of the rows. Right bits, if you have a row, then definitely have a right element, rightmost element. But I mean, first we have to go through the rows. Let's do the first thing first. So here, let's go through rows. So row will be starting from row 1, okay? Because we're going to skip row 0 since the row 0 is here. Now notice this I is an index of a character inside the original string. This is an index of a row, right? So this is first row, last row, and this is row in between. So row should be less than what? R minus 1, because R minus 1 is the index of the last row, and last row is already processed here. And plus plus row. Okay? So that way, we're going to deal with all of these rows. And now we need, for each of these rows, we need this element here, and then this element here, right? So it's potentially possible that when we go through all of these rows, not even this element exists. Yeah, let's say the word is very short and the number of rows is too big. Let's say this is 500, right? So when I go through these rows outside, yeah, so some of the rows will be completely empty, okay? Some of the rows will be completely empty, and we have to keep that in mind, okay? We have to ensure that our program still works properly, but most of the time, this character, the first letter will exist and the second may not exist, okay? I think that makes sense. Okay, but we need to figure out the indices of these guys, okay? And I'm going to do the same technique. I'm going to figure out the index of this character and this character in the very first cycle. And then each time I'll be adding delta to move to the next pair, okay? So let's say I'm working on some row with this index. That's a variable, yeah. And the index inside the first cycle, index of this letter in here, you can guess is the row itself, right? So row 0, row 1, it's the first character. It's this one here, okay? So let's try to reflect this. So here we have a loop. Whatever row I'm working on, let left be row itself, okay? Now left must be less than s length. And that condition ensures that even if somehow rows don't even exist anymore, we're not going to go into the inner loop. And that inner loop, the fact that we have this condition here, will protect us from kind of going over the board, over the end of the input string, yeah? So left will be incremented by D, okay? And if we were only dealing with these left characters, yeah, with these left characters here, then what I would have to do is something very similar to this, right? So take answer and plus equal s left, right? S left. However, I also need s right. So what we have to do here is say left equals row, right equals something, right? And then right also needs to be incremented by D. But I can no longer check something like and right is less than s length. Cannot check that here because this might kick me out too early from the loop. Because if the right element does not exist, there still could be a whole bunch other left ones remaining. So this will kick me out of the loop too early. So I cannot put this here, but instead I will use this like a private little condition, ensuring that if right is less than this, then this. You could potentially, for symmetry, also do a similar statement, similar if here as well, but let's not do it for efficiency. I think that's how we should probably do it. Now, provided that I haven't really messed something up, this should pass the initial tests. What did I do? Character 38, expression expect. Oh, right. Sorry. I need something here. Sorry, forgot about that. Yeah. So I need to initialize the left with the index of this left element inside the first loop. So it's what is that? Where is it? It's, I don't know, maybe it's this one, right? But how do we find this index? I mean, that's the question. I mean, it's probably this one, but how do we find the index of this one inside the string? Right, so notice that the left and right are equidistant from the bottom here, okay? So for example, if you were looking at left and right here, then this left is the index of the last row minus 1, and this is the index of the last row plus 1, right? Because we're going like a zigzag, okay? So the sum of these left and right will always be twice the index of the last row. The index of the last row is r minus 1, and twice r minus 1 is our D, okay? So that means left plus right is twice r minus 1, which is D. So if we knew L, and we kind of already know L, we could say R equals D minus left, correct? So R is D minus left. Beautiful. That's easy. So here we would set this to D minus left. Now, left and row are going to be the same at this point when this is calculated. So here you could say row, but I'm going to leave it left. This will work. And this is probably intuitively better explanation what's going on here. Yeah. All right. Let's try submitting this again to, no, not submitting, but running against the pre-tests. Keeping fingers crossed. Time limit exceeded. Why did we exceed time limit? Because of what? So row here, left plus D, right. Just very quick check. That cannot go into an infinite loop. This outer row cannot go into an infinite loop. This cannot go, well, oh, no, it can, sorry. Okay, so, because D could be 0. D could be 0. That's a horrible thing to miss. So, if R is 1, so if you have a single row, if you want to rearrange your initial input string into a single row, then our algorithm won't work. So we could just do this. Yeah. So just kind of short circuit our algorithm. I think I should have guessed this while writing this. Okay, now this passed the pretest. Let's see what happens with the actual full suite of tests. Okay, and I think this is a slightly better result, yeah, as expected. So first of all, we passed, and we beat about what? 79% of solutions in terms of time, and less than half of the solutions in terms of memory. Again, I mean, this is probably the inefficiency of JavaScript or TypeScript, same thing, but this language itself. Because, I mean, it's really hard to imagine who used less memory than this. And it's like over half of the solutions. So what we used was, I mean, we just created this D. This is just a shortcut. I mean, we don't have to create this variable at all. Just every time we'll just replace D with this expression. And then we use a single variable here. It will probably be reused in this other loop. So single variable, kind of a different, it's not a different variable, it would be probably the same location in memory. And here again, this will be the same location in memory. This could be, I mean, compiler would probably optimize that. So one variable, integer, second numeric variable, second same thing, and third and fourth. So we have 4 integers in addition to these, and we still had over half of the solutions beat us in memory efficiency. This could be just inefficiency of TypeScript. Okay, that's good enough.